Okay. Yes, Gombe, hi.
Um, let's pray. Let's have a talk word of prayer. Almighty and everlasting Father, we thank you for the gift of we thank you for all that you have food and everything. That's that you can do this. And your Holy Spirit guide us and you help us be able to apply this time for you. Thank you for your good and your mercy. The mighty name of Jesus.
Okay, thank you so much, Gombe High School, for the word of prayer. I would like to welcome everyone that has joined this call. Thank you so much for joining, and we are happy to have you here. We have already shared the seminar questions, the items we are going to discuss, and at this point, allow me to welcome our facilitator, Mr. John, to start off the discussion. Mr. John, you are most welcome.
Yes, hello everyone. I hope we are all fine. Thank you so much, Gaia is Gombe High School for the prayer. I want to thank Mr. Kaziba for this effort. So, as usual, we've been having our facilitation from the different disciplines, and this afternoon, we are very happy to have physics. I'm Bakayana John. I'm also a teacher, Gaia's High School. I hope you can hear me wherever you are. So just like we've been doing before, it's not going to be a teacher-centered. Mine is to guide, throw in here and there what might be necessary. But we shared the questions. You feel free, respectively, to share or to discuss any question that you've already gone through. I will be on a lookout for those who can take us through different numbers. And without wasting time, you can feel free to let us know which number you can take on, and then we allow you share. Okay, if you're on any of the platforms, I think you can access the questions, the seminar questions that Mr. Kaziba shared. Do we have a volunteer to start or to begin with, to take us through as a lead? Then the rest of us will be guiding here and there. Yes, if you can access WhatsApp, I think the questions are there. Maybe we can resend the questions, but they are there in our different header platforms. Okay, as we are waiting for those who received the questions, maybe we can start with, I can share some of the questions here. Okay, did you receive something like this? Okay. Okay, fine. Okay, fine. So, I think I will have one volunteer to act as a tentative coordinator, one who will be reading for us the questions as we continue with the solutions. So, do we have a volunteer who will volunteer in reading for us the questions? Yes, gone by school. A certain construction company built a theater near a hospital. In this theater, they installed blue and red colored lights and speakers at the front. The management also intends to install mirrors in the changing rooms, though still puzzled over which choice to make. One evening, two friends agreed to attend a show organized in the theater, and they came with one dressed in a yellow dress and the other in a cyan dress. When they entered, they both sat in front, close to the speaker, and wondered how long the back wall was from where they were seated. Still, while inside the theater, they noticed that colors of their clothes kept changing and that there was a second sound similar to the one produced from the speaker, which was heard after an interval of time. These made them confused. So then the questions are, we are given a hint, speed of sound in air is that 330 meters per second. As a student of physics, advise the management of the theater on how to ensure that hospital is not disturbed by the noise from the theater. Number two, which type of mirrors would you advise the management to install in the changing rooms? State reason for your responses. Explain to the two friends why their clothes were changing color. Hope that two friends determine how far they were seated from the back wall if they heard the second sound after 0.1 seconds. So the question in all this element of construct, we have a number of chapters combined. So as you are reading through this item, you realize that there is a mixture of chapters from which we can derive the required responses. So as you read through, your mind should be open and wide to which area am I dealing with at this particular point. For example, if you see that in a question they have talked about blue and red colored lights and the speaker at the front, that should give us a certain hint. Well, the question hints about installing mirrors, then that is optics. That's another hint. On evening, two friends agreed to attend a show organized in a theater, and they came with one dressed in yellow dress and the other in a cyan dress. That's another hint. That is from colors, not so. When they entered, they both sat in front close to the speaker and wondered how long the back wall was from where they were seated. How long? Now that one should click in our minds about echo. That is now waves. Still, while inside the theater, they noticed that colors of their clothes kept changing. Yes, we say that should be under colors. So what I'm trying to say is that as you read the item, they keep hinting on the different areas of the chapters that make up the area or the element of construct. So for every point, it's important to highlight, whether using a pencil, you underline that particular information, or you can highlight or you can write it somewhere. For example, much as the item is detailed, but they are key. There is key information that I need as far as answering this item is what? As far as answering this item is concerned. So I said a certain construction company. Now, as I read through and giving some insights and guidance, we should do it together. At the end of the day, when I ask questions, I expect people to put up hands and we do the item together. Is that okay? We do the item together. So I'm just guiding on what is expected of us. Certain construction company built a theater near a hospital. In this theater, they installed blue and red colored lights and a speaker at the front. The management also intends to install mirrors. So if I were you, I would underline some things here that would guide me later as I'm answering the questions. Install mirrors in the changing rooms, though still puzzled over which choice to make. One evening, two friends agreed to attend a show organized in the theater, and they came with one dressed in a yellow dress and the other in a cyan dress. So this is colors at the back of your mind. Now, the mind starts clicking. Yellow is a combination of what and what. Cyan is a combination of what and what. As you are reading through the item, the mind should also be thinking through what is expected of me as one who is going to attempt this item. So when they entered, they both sat in front close to the speaker and wondered how long the back wall was from where they sat. How long the back wall, this is also a very important statement. It clicks in my mind of what is expected of me. Now, how long, if I'm interested in knowing the distance between the source of the sound and the sound goes and comes back, that one should, in my mind, the echo idea clicks in. That is sound waves. Still, while inside the theater, they noticed that colors of their clothes kept changing. This is another important statement. The changing of colors, you know what happens when colors mix together. And that there was a second sound similar to the one produced from the speaker, which was heard after an interval of time. So, excuse me, we are given a hint, and then there comes the questions. Here comes the question. So, now from that background, advise the management of the theater on how to ensure that the hospital is not disturbed by the noise from the theater. So I would love it if people put up hands and we go through this together. And I also assume that we have somewhere we are taking notes of this. So where it requires correction and guidance, that one we shall do it. But I would love that someone can put up the hand and share with us what you expect or what is expected from this item or the task. Advise the management of the theater on how to ensure that the hospital is not disturbed by the noise from the theater. As you put up the hand, you tell us what is expected of this particular part of the task, and then the response. Yes, Harrison. Harrison, you can unmute. Okay. Harrison, you can unmute.
All right, we are ready to go. Here is a student who is ready to give in some reactions. Yes, please.
Okay. In order to prevent the theater rooms from being disturbed by sound, there is one thing that must be done. The walls of the theater must be constructed with having soft porous materials. These soft porous materials will help absorb the sound waves from the theater room, hence making sound not be able to be heard by the people in the theater. That is how this I can explain about this. Thank you so much.
Did the rest of the members hear? Yes? Okay, let me share again. Harrison, meanwhile, you can repeat kindly. Yes, please. Yes, Harrison. Any other person? Any other person? Yes. Another one, feel free to to share. Yes? Okay, in the interest of time, I think we can continue. Let us have a few responses here. So the question was advice. Advise the management of the theater on how to ensure that the hospital is not disturbed by the noise from the theater. So among what we expected, to give I'm just mentioning a few. So, for example, installing acoustic soundproofing materials, or using double-glazed doors and windows to reduce sound leakages. I mentioned them here. I think I can share them with us so that people can also take note. Yeah. So double-glazed doors and windows to reduce sound leakage. Direct speakers inwards using directional sound system. Control the volume of sound, especially during sensitive times. And also, okay, we are saying plant trees or install sound barriers between the theater and the hospital. So I just try to put down a few. We can also think through some more. Okay. Through the second part, because of time, which type of mirrors should you or would you advise the management to install in the changing room? State reasons for your response. So in the changing room, which type of mirrors would you advise with the reasons? Yes. Any trial? Yes, please. Yes, Wairaka. You can go ahead and unmute. Yes, we're in part B. Which type of mirrors would you advise the management to install in the changing room? State reason for your response. You can in case you fail to unmute, you can type in the chat, yeah? I can always read the responses from the chat. Feel free to type in the chat. Okay, someone is saying plain mirrors, very good. Concave mirrors, very good. So can you kindly explain why? Okay, some people are writing answers in the chat, which is very good. Eh? Okay, so now when you state concave mirrors, when you state plane mirrors, when you state convex mirrors, you should back up your answer with a reason. Plane mirrors provide upright image, yes, which is true. Any other? Convex mirrors form upright and real images. Do convex mirrors form real images? No. Convex mirrors don't form real images. So now we have plane mirrors, we have and the reason, someone has given a reason that plane mirrors form upright images, which is true. Do plane mirrors form real images? No. Plane mirrors form virtual images, not so. Plane mirrors form virtual images. Okay. Let us try to see. Some few responses here that I have. So we are saying that the management should install plane mirrors in the changing room. Why? Because plane mirrors form virtual, upright, same-size images, which are ideal for personal grooming and dressing. Yes, this was my reason. Other mirrors, concave or convex. Now, these ones would distort the appearance of the user. Why? Because in most cases, unlike or unless for special considerations, but concave mirrors form the images whose size is different from the size of the object. I said unless or unlike for special considerations, like for example, where the object is placed at the center of curvature. But if you want a real image of the person or real image of, not as in, if you want the same you, though virtual, because if you are using plane mirrors, then we say that plane mirrors show or give a virtual but upright image, same size. Convex will give a diminished what? A diminished image. Concave mirror, depending on the position of the object, the image can vary. That okay? But thank you so much for the responses in the chat. That is our part B. Let's go to part C. If there is any question, feel free to write in the chat. That is, if you can't, if you find it a bit hard to unmute. Okay. Another question. Explain to the two friends why their clothes were changing color. Explain to the two friends why their clothes were changing color. Who can give us a hint? Or a response on this question? Yes? Due to color filtering, their clothes change the color due to color mixing. It's because color reflection and filters. Their clothes change the color due to color mixing. I read that. Will there be soft copies? Yeah, we shall share the soft copies. But now let us brainstorm. Let us understand and get the concepts together for now. So thank you so much for those responses. Then I will share what I have here very fast because we don't really have a lot of time. Okay, our part C. Remember, when we go back to the question, we have yellow and then cyan. So under color mixing, we need to know what happens when a yellow dress is in maybe a green light or it is in a red light, depending on which color or which type of light is there. Is that okay? So the perceived color, this is what I have. The perceived color change of their clothes is due to the presence of colored lighting in the theater. We say that a yellow dress reflects red and green because yellow is a combination of red and what? Red and green. Under red and blue light, no green, it reflects mostly red or appears black. Then cyan dress reflects blue and green. Why? Because cyan is a combination of blue and what? And green. And we are saying that under blue and red light, no green, it reflects blue or appears dark. This change is due to the absence of green light in the environment affecting how colors are perceived. That okay? Any question in the chat? Yes, for someone is saying for the yellow is because it reflects blue. It reflects red and what? Reflects red. Did you say reflects red and blue? That is for yellow. Did you say reflects red and blue? Maybe we can remind ourselves very briefly and simply. Yellow is a combination of what and what? Yellow color is a combination of and someone is saying red and green. Is it? Okay. Red and green. How about cyan? Cyan is a combination of what and what? Green and blue. Okay, very correct. So cyan is a combination of green and what? Green and blue. Now, from the very simple concept of light and why we are able to see colors of objects, I know that we've been told you are able to see blue because blue color is reflected into your eyes. You are able to see yellow because a combination of red and green is reflected into your eyes. That's why we're able to see yellow. So meaning that any color that you're not able to see, it means it is absorbed. It is absorbed by that object. So reflection of yellow and green or reflection of red and green implies yellow what? Implies yellow color. Is that okay? Karen, we would go ahead and ahead, but our time is not so much. Let us try to think through the next question, which is part D, unless if there is any burning question. So we are here. Help the two friends determine how far they were seated from the back wall if they had. Okay, help the two friends determine how far they were seated from the back wall if they had the second sound after 0.1 seconds. So what does this question calls us to do? Or what does this question requires us to do? Someone give us a hint, then I'll go ahead and take us through, but you can give us a hint. What does this question requires us to do? Now, those who are requesting to record, the session is already being recorded, so you'll be able to access it on the Help platform or the Help YouTube platform. So kindly, let us first go ahead. We have so far looked at one number, which is not yet done. So let us first pay attention to these questions, and then I will send the solutions, and also you'll be able to access the recording. So part D calls for what? Let me check in the chat. Calculating the distance of sound. Very good. The distance of sound. Do we agree finding the distance, calculating the distance of sound? Do we agree with what this St. Elizabeth is saying? Yeah, he has gone ahead to give us the method. Velocity is 2d out of time. There is something that many students, a mistake that many students do when we are calculating for the velocity. We know that velocity or speed is distance over time. The difference between velocity and speed, you know that one velocity is a vector, then speed is a what? It's a scalar quantity. But the mathematical expression or formula is the same. Speed is distance over time, and so is velocity. So if speed is distance over time, can someone tell us why do we always have to multiply distance by 2? For this case, why do we always have to multiply distance by 2? Because it would have been velocity Okay. Let me check in the chat. Distance is multiplied by 2 because sound travels to and from that position. That is twice the distance. It travels the same distance to and from. Thank you so much. It moves to and fro. Sound moves to and fro. Thank you so much. So we multiply. Very good. Someone has already calculated the distance. So we multiply the distance by 2 because sound travels to, and it travels to, T double O, travels to and what? To and fro. So I did my simple calculation here. I'm declining all requests for recording because they are becoming very many, yet we have to concentrate. So I'm declining all. But we shall access the recording on YouTube. So this is a simple calculation. Total distance is speed times time. And the sound travels to the back wall and reflects back. So total distance is speed times time, which is that times that. So alternatively here we could say try to look for something to write. Okay. You know speed is equal to distance over time, which distance is 2. Why? Because sound travels to the wall and then does what comes. So it travels twice the distance between the source and the area of reflection, which is the wall. That's why I multiply 2 times small d out of what? So the velocity is given 330, 2 times d out of, the time is 0.1. So that means my distance would be 330 times 0.1 divided by what? Divided by 2. Is that okay? Okay. That's all for number 1. We can go to number 2 very fast. Number 2, any volunteer to read for us, or it might take some time. An elder in a certain village was narrating to his family members his experience of a visit to London. He said that in London, daytime was longer than nighttime, with 16 hours of day and 8 hours of night. This was unique to family. He also added that stars were rare organisms that died at daytime and resurrected at night. Furthermore, he stated that the shape of the moon kept changing over a monthly cycle. The family members, in comparison, said that some of the elders' experiences were equally observed in their village, but unfortunately did not understand these occurrences. Then, as a student of physics, helped the elder and his family to understand how the unique observation in London came about. Like I mentioned, you are not just reading this item, but as you are reading, you are figuring out what are the key parts in the item. So, what am I expected, or what is expected of me? So as you are reading, highlight, maybe using a pencil, the key important parts of the question or the item. An elder in a certain village was narrating to his family members his experience of a visit to London. That's a very good statement, but let me continue. He said that in London, daytime was longer than nighttime. Now, this is a very important statement. Daytime was longer than nighttime. They have even given the difference, whereas here in Africa, or in Uganda particularly, we have 12, 12, 12 day, 12 night. Now, this is a unique scenario where they say at night it is 16 hours, and then you only have 8 hours. No, during that day, it is 16 hours, and you only have 8 hours overnight. This was unique. He also added that stars were organisms that died during day and resurrected at night. So I underline just the word stars. In other words, if I'm to start putting some brief information of what I'm expected, what are stars, how are they formed, or maybe why do they appear the way they appear. Now that statement is, in my mind, is replacing the one that they are saying, or they are talking about here, stars dying during the day and resurrect at night. Of course, as a physics student, you get a click, or you have a hint of what is supposed to be. But nevertheless, we are still continuing to read the question. He stated that the shape of the moon, shape of the moon kept changing over a month cycle. The family members, in comparison, said that some of the elders' experiences were equally observed in their village. Unfortunately, they did not understand these occurrences. Now, as a physics student, explain how the unique observation in London came about. Which unique observation? Remember, maybe I can guide that. Why do you have to underline some key parts of the item? Because every time you answer the particular part of the item, for example, part A, you go back and read again the item. Part B, go back and read so that you get clearer the information. Underlining guides us in getting the concepts better and faster, so that if I'm on part C, I may not need to go and read the whole item again. Remember, time is also another factor. So these that I underlined are summaries of the item. They are summaries of what the item is asking or is expecting of me to respond. Is that okay? So therefore, that's the importance of highlighting or underlining the key parts of the question. So how the unique observation in London came about, the first thing I underlined, day was longer than night, with 16 hours of day and 8 hours at night. So meaning that if I'm to answer part A of item 2, my response or has to make clear understanding or has to throw more light of the first part I underlined. So your response should be, why does day or why does daytime or why is daytime longer than night time in London? As simple as that. So can I have some responses from the chat now? Because unmuting became somehow tricky, but let me check in the chat. Due to the rotation of the Earth on its axis, very true. It's due to the rotation of the Earth, tilting of the northern hemisphere about the sun, very true. Maybe the other thing that I need to guide us as we are continuing in this new curriculum of ours, it is always very important to give more than one facts. Remember, the way we are marked, the more the responses, the better the result. For example, if you give only one fact, you get one score. Someone gives more and more facts, that person gets more score. And from the more scores that you get, the aggregated points become more. So that's why it is, you are correct to say, revolution of the Earth, tilting of the northern hemisphere about the sun, but you earn only a score. So when you are responding, you have to go a little bit into details. Let the points be more than one. That okay? Okay. People have given hints. Now I can share mine. Parabek Secondary School, kindly respond. You can type in the chat. The microphone became so tricky to unmute, but you can write in the chat. All the responses, kindly let's write them in the chat. Don't distort our screen, yeah? I'm so sorry. I had unmuted and then I forgot to. I had muted and I forgot to mute to unmute. Sorry. Okay, let me reply or let me respond to this question again. Let me say what I've just said again. So I've said that these misconceptions still exist where people think that stars they are alive during night and then during the day they die. So for us who are blessed to have knowledge of the things surrounding us or the things around us and also knowledge about the universe, we can reach out to people with this kind of misconceptions using the knowledge of physics. We can really give better responses to such allegations, yeah, and unclear misconceptions. So really, the observation of stars at day and night is not in any way connected to like dying of organism, as this organism die and then resurrect at a particular time. But these are things that we know that we can explain with a background of the solar system and the universe, things that we've studied in senior theory. So like I say that I'm waiting for the responses from the chat. Feel free to share. I begin with them and then I'll also share what I have. Any response? In brief, why are stars? Why do stars appear during night and then we don't see them during the day? Yes. Okay, we can't get the question. The question is why uh let me read it again here. Okay, due to the rotation of the earth. Let me read it again here. From our question, from the scenario, we have that there is a misconception that stars die during the day and resurrect at night. For you who have studied physics, can you explain or can you use physics knowledge to explain that this is not the case, that stars really die and resurrect? Can physics tell us the real reason why we're able to see the stars at night and during the day we're not able to see them? Okay. Okay. Let me try to put it somewhere. The sun is bright. Why do stars appear during night? Yes. Thank you for sharing the question on the chat. It is because during the day the sunlight is brighter than the light produced by the stars. And at night there is no sunlight, hence they are seen at night. Okay, true. At night the light intensity is greater than the stars. Emissions, making it invisible. Okay. It's because the sun's light focuses on different parts of the moon, giving the illusion that the moon is changing in shape over time. Oh, this one is answering. We are still on part B. The sun is the nearest star on the earth, so bright that it overpowers the stars. Yes. Stars are always present during day. Sunlight is much brighter, and scatters in the atmosphere, making the stars invisible. Yeah, that is also true. They just become invisible due to the sun's brightness during the day time. Okay, all these are true responses. So I'll also just add on a few things, and then we go to part C. I don't know, someone is writing on the screen. I have to first stop sharing. Okay, need to first stop sharing, then I reshare again. Uh, Not so much different from what you people have given for party B. For those who missed party A, the response is there. Okay, so for party B, the elders believe that stars die in the daytime and resurrect at night is a misconception. Stars are always present in the sky both during the day and night. However, during daytime, the sun's light is so bright that it scatters in the Earth's atmosphere and outshines the faint light coming from stars, making them invisible to the naked eye. At night, in the absence of sunlight, the stars become visible again. I hope that is clear. So you're saying that during the daytime, the sun's light is so bright that it scatters in the Earth's atmosphere and outshines the faint light coming from the stars, making them invisible to the naked eye. At night, in the absence of sunlight, the stars become visible again. So that is our part B. We go to part C. Part C was asking for why and how the shape of the moon keeps on changing over that period. So why does, now here I underline the statement in our item that is calling for the shape of the moon kept changing over a month's cycle. Someone can explain to us this. You should have learned this. Shape of the moon changing over a month cycle. In other words, why and how the shape of the moon keeps on changing over a month cycle. Yes. Okay. Let me check in the chat. Due to the stages of the phases of the moon, um, yes, you are too fast. Very sorry. We will share the recording. We'll share these responses, but we have some good work to do here. Just pay attention. Just make sure that you're not distracted. So someone is saying that why and how the shape of the moon keeps on changing over that period of time. Which period of time are they talking about? Over the monthly cycle. So I'm getting some good responses from the chat. Phases of the moon. Remember I said that when you simply say phases of the moon, it is correct. You get a score. But the more the correct scores, the more the aggregated points on a particular question. That's why we prefer that if you know more than one facts, it's better to give all the facts that you know on that particular question, but putting in mind the time constraint. Is that okay? So we are getting very beautiful responses here due to the position of the earth between the sun and the moon, which is true, due to the apparent movement of the moon around the earth, angle of observation from the earth, due to the change in the moon's actual form, orbital motion of the moon around the sun, around the earth, because the moon keeps on rotating around the earth, making it to be seen in different shapes. All these are true. Two more, due to the position of the sun where the moon rotates about to get its light. Okay, that's very good. I have a few here, like I can add on also. Remember, I said that when anyone is writing in the screen, you are making it difficult for me to use the screen. I have to first stop sharing, then I reshare again. Okay. Let me reshare again. I have a few responses here just to add on what you people have given. All the responses are very good. I'm just adding on a few. So this is what I said. The changing shape of the moon observed over a month is known as the phases of the moon. Someone mentioned it very correctly. But when you simply say phases of the moon, that is one score. On a part or on a question, there might be more than 5 or even 6. So that's why it is very important that each fact that you know, you write it on that particular question. So these phases, now you break down the phases. Don't simply stop at the phases of the moon. Break them down. They include the new moon. The moon is between the earth and the sun. The side facing earth is dark. Then the first quarter, half of the moon's disk is illuminated on the right. Full moon, earth is between the moon and the sun. The entire face is illuminated. Then the last quarter, half of the moon's disk is illuminated on the left. I didn't show them with diagram. Hopefully when, before sharing, I'll put in some images for us to get it clearer or a little bit better. This cycle takes about 29.5 days, known as a lunar month. So, in short, someone gave us a response. It is because of the phases of the moon, and other responses that people have really given. They are very good and very correct. Like I say that I just add on a few things on what other people have. Is that okay? Okay, we got section B. Section B, that is item 3. Says, a business lady operates a restaurant which serves food and drinks. In the morning, as she was driving her car to her restaurant, remember what trick? As you are reading through the question, maybe let me rephrase it better for us to understand it well. You first read through the whole entire item, then you can go back and read carefully part per part before you highlight. A business lady operates a restaurant which serves food and drinks. In the morning, as she was driving her car to her restaurant, it developed a problem. There was a lot of steam coming from the bonnet and the engine stopped working. The mechanic she invited told her that the engine was overheated because there was little water in the radiator. After filling the radiator with water, the car started working. When she reached her restaurant, she prepared 0.02 kilogram ice cubes at negative 10 degrees Celsius for customers who wish to add them to their drinks. She then steamed the matoke for lunch and proceeded to make her special drink that she serves out in plastic glasses that hold 0.5 kilogram of the drink. We are given the value of the specific capacity of water, specific latent heat of fusion of ice, and then the Tassic's come. So here we are supposed to help the lady understand the features that make her car radiator efficient for its purpose. Number 2, identify the various states of water that she used that day. Various states of water that she used that day. Explain why each of the states of water works very well for the purpose it served that day. Determine the specific capacity of the special drink, given that a customer needed 4 ice cubes to reduce the temperature from 30 degrees Celsius to 10 degrees Celsius. So I've read through the item generally. Now I go through reading, picking out the required information. This time I go a little bit slower. A little bit what? Slower. Okay. A business lady operates a restaurant which serves food and drinks. That's a good statement. But I'm looking for a particular statement that is part of what is supposed to guide me in responding to the item that is asked. In the morning, as she was driving her car to the restaurant, it developed a problem. There was a lot of steam coming from the bonnet and the engine stopped working. That's a very important statement. A lot of steam coming from the bonnet and the engine stopped working. The mechanic she invited told her that the engine had overheated. Engine had overheated. I can underline that statement. Engine had overheated because there was little water in the radiator. Okay. After filling the radiator with water, the car started working. By the way, maybe I can ask this question just for us. It's not part of these questions, but for us to understand. Why is water used in car radiators? Why is water used and not any other liquid? Yes, can someone tell us? Because I might forget this question that is very important. What do they use water as a coolant? Let me check. People write responses in the chat. Now, high specific heat capacity. Everyone knows high specific heat capacity. Now, who can break it down for me? High specific heat capacity. Who can break it down for me? High specific heat capacity. Someone might be there who needs to know what the word is. What does it mean by stating or saying high specific heat capacity? Can someone give us that explanation? I'll be glad if someone gives it to us. Water has a high specific capacity and it is readily available. It can absorb more heat. Can someone give us an elaborate reason? Why does water has a high specific heat capacity? Because it has a higher heat capacity compared to other liquids. Because it has a high specific heat capacity, so it requires this one has given it out. So it requires a lot of heat to raise its temperature by 1 degree Celsius. This one has given in more details. So water is used as a coolant because of its high specific heat capacity, which is 4,200 joules per kilogram per Kelvin, meaning that you need 4,200 joules of energy to change 1 kilogram of water by 1 Kelvin. So that's a lot of energy needed. 4,200 is a lot of energy needed, meaning that if you are to change water by 1 Kelvin, the energy must be 4,200 joules. So it makes it a good liquid to be used in car radiators because of its high value of specific capacity. Is that okay? So we go back. Now, I had to mention this one because almost the entire question rotates around that particular part. So it takes long time to warm up. That is very correct. Yeah, in fact, someone is just explaining it to a layman's language, understanding water takes long time to warm up, which is very correct. Thank you so much. Okay, let me see. We go back to our question and we see how now we apply that knowledge in coming up with a required response. When you see me stop sharing, it means someone is already using the screen, so I can't access it fully. I have to stop and reshare again. Okay. So we are here. Understand. Okay. Part A is asking us to help the woman understand the features that make her car radiator efficient for its purpose. In other words, what are the features that make a car radiator efficient for its purpose? Let us brainstorm. I know that you must have looked at car radiator system. What are the features that make it efficient for its purpose? I'm declining. For those who request to record, we shall get a recording on YouTube from the headed platform. Yes. The car radiator uses water. It has a large surface area. Some other responses. Feel free to share the responses. Remember, I told you that I just add on what you give us. Cooling fins, fan, black color. It's ventilation. It's painted black. Very good. Remember that these responses, once we gather them together, they make up a solid response. I told you the more the correct responses, the more the answers. Don't stick on just one response and stop at that. Even if a question says state, you don't have to give just one response. Give as many as you can. Is that okay? Most car radiators are painted black. This is due to it being the most efficient color for heat radiation, because it is also a good absorber of heat, which makes it efficient for its purpose. Someone was asking why painting color black. They have given you the response. A car radiator is black, making it a good absorber of heat, hence making the engine to cool. Okay. Thank you so much. I'll also share a few that I have here for us. Has fins due to overheating leading to reduction of water through vapor, which is correct. Okay, let me also share a few that I have here. Uses water, someone gave that response, and water has a high specific heat capacity, allowing it to absorb a lot of heat from the engine without quickly raising the temperature. Yeah, that's the reason as to why water is used, because of its high specific heat capacity. The radiator has metal fins, usually copper or aluminum, that are good conductors of heat and increase surface area for cooling. Someone mentioned the surface area somewhere, which is very true and very correct. Another one, it allows airflow through its structure, which enhances cooling by convection. Okay. These are some of the responses. There are many, but like I said, I just add on a few so that we can go to something else. Our time is not that a lot. Is that okay? But I want to thank you so much. So far, the responses are very good. Let's go to another part or another question. Another part says, identify the various states of water that she used that day. Various states of water that she used that day. We go back to our question. We revised. There was a lot of steam. If I were you, I underline that kind of, or that state. There was steam, a lot of steam coming from the bonnet, and the engine stopped working. The mechanic she invited told her that the engine had overheated because there was little water. They mentioned the steam, now they are mentioning water. When she reached her restaurant, she prepared 0.02 ice cubes. Okay. -10 degrees for customers who wish to add them to their drinks. She then steamed the matoke for lunch and proceeded to make her special drink that she serves out in plastic glasses that hold 0.5 kilograms of the drink. So from that statement, we should be able to respond to part B. What are the various states of water that she used that day? Yes. Gas, solid, liquid, ice, steam, liquid. Thank you so much. Can someone give us some detailed explanation? Gas, where and how? Solid, where and how? Liquid, where and how? Ice. Okay, solid is mentioning ice. Gas is steam. Liquid, water. Someone is saying plasma. Do we have plasma really? I don't think so. Plasma, those are ionized gases. Do we have them in this case? Okay. Thank you so much. Thank you so much. Thank you so much. The responses are really very many and timely. So I'll add on a few from what I also have here. Gas, that is steam observed from the radiator and while steaming matoke. Solid, prepared for customers' drinks. And also liquid, water or drink in the radiator and the drink served. Is that okay? Yeah, like I say that we have very beautiful responses. I also just add on a few and then we continue. Part D, Part C, explain why each of the states of water works very well for the purpose it served that day. For the purpose it served that day. Explain why each of the states of water works very well for the purpose it is served that day. Can someone give us a hint on what that question requires? Let me repeat a question. Explain why each of the states of water works very well for the purpose it served that day. I'm seeing some responses in the chat. Gas coming out of the bonnet. Steam carries a lot of latent heat for cooling, for cooking. Very good. Steam carries a large amount of heat effective for cooking. Steam was due to high heat. Liquid because it has a high specific heat capacity for cooling. Steam has a high latent heat. Now here comes another question. Meaning of latent heat. Can we help some of our friends? Just like we understood what latent heat mean. Can someone throw more light on what, just like we understood what specific heat capacity mean? Can someone throw more light on what latent heat means? When you say hidden heat, you are correct, but maybe it's because the solid, okay, hidden heat, but now what is hidden heat? I want someone to give a detailed response to help our friend. What does the word latent heat mean? When you say steam has a high value of latent heat, what does it mean? Someone saying that latent heat is the hidden heat required to raise a substance by 1 kilogram per 1K per kilogram. Okay, not the definition. The definition we can always read, but someone to break it down to help us understand what latent heat mean. I'm looking for heat needed to change the state of a substance without changing temperature. Amount of heat required to change 1 kilogram of water by 1 degrees. Amount of heat needed to cause the change of state at constant temperature. Yes, all these are correct, but I'm still looking for that particular response that can help someone understand what the word latent heat mean. Latent heat mean experienced after the temperature reaches its boiling point, absorbed energy. Okay. So when we say heat, when we say steam has a very high value of latent heat, what does that mean? Okay, latent heat is the quantity of heat required to change the state of a substance without change in temperature of the substance. So when a substance absorbs heat, there are two things. Number one, there is change in state. And then after change in state, there is change in temperature. So for example, if you heat ice cubes or simply ice, ice is changing from ice at 0 degrees Celsius to water at 0 degrees Celsius. Someone would ask, I don't see any change in temperature. What is the heat being used for? So the heat that is absorbed is now breaking the intermolecular forces of this ice. It is doing a lot of energy, or it is doing some work in making the molecules of the ice loose, so that at a particular point they can start sliding over each other. So we say that when molecules start sliding over each other, then that is a liquid state. So when ice starts absorbing heat, the heat that it absorbs, the work that is done inside or internally in the ice, it is absorbed in changing state from ice to water without changing temperature, because like I said, first we have to break the intermolecular forces further. We can then slide the molecules past each other, then a liquid is formed at the same temperature. Then at that moment, temperature can start rising. So the work that is being done, or the energy that is needed to change from solid ice from solid water, that is ice, to liquid water, that type of energy needed is what we call latent heat. That's why sometimes they call it hidden heat. and so on. That okay? So now we go back to our question. Of course, people have given responses, but in heat as a theme, and also chapters that we have there, therein, you need to understand not simply cramming, but understand just a few concepts. Then you'll be good to go for the entire chapter or theme. Understand, not cramming, but understand what specific capacity means, what heat capacity means, what latent heat means. Those three, then the rest. Even these calculations become simpler once you know what latent heat mean, what is specific capacity mean, what heat capacity mean. Those three, you are good to go in heat. Okay. So now our question was, I need to first stop sharing, then I reshare again. When I get somehow stuck, need first stop sharing, then I reshare. Okay. I reshare again. So this is our question, and then we on part C explain why each of the states of water works very well for the purpose it's served in that day. I think we finished this one. Let me just see a few things that I had to add for part C. This is what I said. Each state served its purpose effectively due to its properties. Steam carries a large amount of latent heat of vaporization, making it effective for cooking food like matoke by transferring heat effectively or efficiently. Ice absorbs heat when melting due to latent heat of fusion, making it excellent for cooling drinks. Liquid water in the radiator absorbs engine heat without evaporating quickly, preventing overheating because of its high specific capacity. So these are our responses for part C. Why each state of water served its purpose effectively. So we said steam carries a large amount of latent heat of vaporization. We've just explained what the word latent heat means. And also ice absorbs heat when melting due to its latent heat of fusion. Is that okay? That fine? Yes. Okay, when I allow multiple presenters, we may get a lot of voices. If there is any question, I request that you write in the chat. Multiple presenters, we shall get a lot of voices. We shall get some interruptions. Kale, part D. Part D, determine the specific capacity of the special drink, given that a customer needed 4 ice cubes to reduce the temperature from 30 degrees to 10 degrees. That is a decrease in temperature. Now, someone should be very specific here. From which temperature to which temperature, determine the specific capacity of a special drink, given that a customer needed 4 ice cubes to reduce the temperature from 30 to 10. Okay. So, anyone to take us through this calculation? Yes. Is anyone able to share? You can put up the hand. I find a way of allowing you or giving you permission to share. Yes. Anyone willing to share? Okay. You can share. I think it is possible. Let me see. If I make you a co-host. Okay. Think you are able to share. Mm-hmm. Core message secondary, you should be able to share the screen and take us through. For those who are working it out, thank you so much. I see responses in the chat. Thank you so much. At this point, if I can get one person to discuss it for us on the screen, I'll be very glad. Mm.
So can you hear me?
Yes.
Okay, but my screen is not loading.
Mm.
So can I just go through?
Mm.
So we are, according to the last paragraph of the scenario, they are saying that when she reached her restaurant, she prepared 0.02 kilograms ice cubes at negative 10 degrees Celsius for customers who wish to add them to their drinks. And now they are saying that the specific capacity of the water is that, and the specific latent heat of fusion of ice is that. So when we are finding now according to the question, they want us to find the specific heat capacity of the drink. And they are saying that it was changed from 10 degrees to 30. So first of all, we shall need the temperature change, which is 30 minus the 10. But I have no way of doing it without sharing the screen.
Are you near a board? A blackboard?
Yes.
How about if you write on a blackboard, someone records you with a video?
It is impossible for now.
Okay.
Yes.
Are you using a phone?
What?
Are you using a phone?
No, we are on a laptop.
Okay. Mm.
But I hope you can see now my screen.
Yes, we can see.
So Now the formula of getting, okay, we begin with the quantity of heat that was required to change the ice, to change the temperature of the ice from negative 10 degrees Celsius to 0 degrees Celsius. So that will be, we use the formula of latent heat, which is Q will be equal to M LF. And now the M stands for the mass of the ice tubes, and the LF stands for latent heat. So, but for the mass of the ice tube is 0.2, and now we have 4 ice tubes. So to mass, which is our M, will be equal to the 0.2 point the 0.2 times the 4. What's the answer there? Which is 0.08. So this is the mass of the ice tubes together used. So now we shall get Q as 0.08 times the latent heat of fusion of ice, which is 33, which is 3,600,000, which is 3,660,000. And when we multiply, what do we get? This one. Yes. So when I multiply, I'll get my issue as 2, 6, 8, 8, 0. So this is the quantity of heat that was required to change the ice from negative 10 to 0. That is it. Can you hear me, sir?
Yes, sir.
Am I on the right track?
Continue. Don't worry, we are going to harmonize.
Okay. So I've got this. So now I need to the question. Please, sir, can you continue?
Okay. Thank you so much. Thank you so much. Thank you so much. Remember, friends, I told you that we are learning together. So let us shape his response together. So we go back to the question. Let me see how I can share again, but thank you so much. So our question said, When she reached her restaurant, she prepared 0.2 kilogram ice cubes at negative 10 degrees for customers who wish to add them to their drinks. She then steamed the matoke for lunch and proceeded to make her special drink that she serves out in plastic glasses that hold 0.5 kilograms of a drink. Okay. So, what do we have here? The important statement to underline here is 0.02 kilogram ice cubes at negative 10 degrees Celsius. So, if ice is to undergo changes, that's if assuming that ice is being placed in a what? In a drink. Is that okay? So we have some ice cubes. We have some ice cubes here. Let me just call them color black. Oh. So we have ice cubes here poured in a drink. The ice cubes are initial at a temperature of initial temperature. Their mass of ice is going to be what? Because they are saying that she prepared 0.4. Mass is 0.02 kilograms. That is each. So we are given the specific latent heat of fusion. We are given specific heat capacity of water. We are given the mass of a drink, mass of a liquid, which is 0.5 kilograms. What else? The change in temperature of a liquid, change in temperature of a liquid is also given here as 30 degrees Celsius minus 10 degrees Celsius, not so? Which is 20 degrees Celsius. This is the change in what? The change in temperature. Remember, it is dropping from 30 degrees to 10 degrees. But something that we shall learn, that as the temperature of water or the temperature of the liquid drops, the temperature of the ice cubes does what? Rise, not so? Temperature of the ice cubes does what? Rise. So we shall have the heat supplied by the ice cubes being equal to or equated to the heat that is absorbed by the liquid. Are we together? So what would be the heat supplied by the ice cubes? How many ice cubes do we have, by the way? Because they said she prepared 0.02 kilogram ice cubes at that temperature for customers who wish to add them to their drinks. She then steamed that special drinks that hold this amount of water. Okay. Okay. So what is going to be the heat lost by, or what is going to be the heat gained by the ice cubes? Heat by the ice cubes. Remember, these ice cubes are changing from negative 10 degrees Celsius to positive 10 degrees Celsius. In fact, let me draw it going upwards to make it a little bit more understandable. I hope you people are following. So the ice cubes are raising temperature from negative 10 degrees Celsius. There is somewhere where there is change in state, but constant temperature. Then from there goes to 10 degrees what? Celsius. So this is ice. So ice goes to 0 degrees Celsius. What is it doing at 0 degrees Celsius? There is change in state. Is that okay? Or allow me to make it a bit more clearer. We have ice, we have water. Ice rises from 0 degrees Celsius, I mean from negative to 0 degrees Celsius. So here there is change in what? Change in temperature. Then from there, from 0 degrees Celsius to 0 degrees Celsius, who can tell me what ice is doing in between that region? Let me say this is A, this is B, this is C. Then there is another region we shall call D. From 0 degrees Celsius to 10 degrees Celsius. So what is ice doing between B and C? There is change in temperature just as the first phase. Now, here there is change in state. That means if I'm to find the energy that is absorbed by ice, the heat energy absorbed by ice is going to be the mass of ice as it changes from negative degrees Celsius to 0 times the specific capacity of ice times change in temperature, changing from negative 10 degrees Celsius to 0. Then it reaches 0 degrees Celsius and change in state. That is mass of ice times specific latent heat of fusion of ice. That is between B and C. Then from C to D, now change in temperature. That is mass. Now it has changed into water. So this is the mass of ice that has changed into water times the specific capacity of water times change in temperature. So that means the quantity of heat absorbed by ice is going to be mass of ice times specific capacity of ice. All these values, we have them. Mass of ice, specific capacity of ice, change in temperature. Then plus mass of ice times specific latent, this is what? Specific, LF stands for specific latent heat of fusion, yeah, of ice. Then plus mass of ice, specific capacity of water, because here ice has changed into what? Into water. That's why we multiply by specific capacity of water, then times change in temperature. So we get the heat absorbed by ice from negative 10 degrees to positive 10 degrees. Say, I have the answer here. Okay, whichever the answer that we get here, this is the heat absorbed by ice. Then we go. Remember, heat absorbed by ice is equal to the heat gained by, heat lost by water, not so? Heat lost by water. Water is changing from 30 degrees Celsius coming downwards to 10 degrees Celsius. That is mass of water times specific capacity of water. The change in temperature from 30 degrees Celsius to 10 degrees Celsius. It is reducing, not so? So since specific capacity, since the heat absorbed by ice should be the same as the heat absorbed by water, it means if I know this value, how do I know that value? I got it from here. the heat absorbed by ice. If I know it, for this I know the mass of water. Of course, 30 minus 10, I get 20. I'll just equate the value of Q of ice I have with the value of Q of water. So this will be Q of ice equals mass of water, specific capacity of water times 20. Yeah, so that means that if I have the mass of water, which is 0.5, heat absorbed by ice, I got it. This is 20 already given. I can get the specific capacity of, water or of a drink. I'm saying water, sorry, but it's supposed to be a drink. Specific capacity of a drink. Replace this W by a what? By a drink. Is that okay? Okay. Maybe I can roughly share the reason as to why I want to check on this response that I wrote here. Yeah, here. Mass of ice. I multiplied by 4 to make 0.08 kilograms. I'm still checking out where I got this 4 from. But otherwise, that's why I didn't share it. This is what I've been talking about. The mass of ice, from ice at negative 10 degrees Celsius to ice at 0 degrees Celsius in the middle. Ice at negative 10 degrees Celsius to 0 degrees Celsius, then to ice at 0 degrees Celsius, change of state. Then from, it has now changed into liquid. That means we have specific heat capacity of water. So the answer that we get here, we go ahead and compute. Now that is heat absorbed by ice. So the heat absorbed by ice by a drink is mass of a drink times the specific capacity of a drink times change in temperature. So here we get 10C. This C stands for the specific capacity of a drink. And then here I say that since by conservation of energy, assuming no heat loss, the heat lost by a drink should be the same as heat gained by ice. That means that 10C I have here equated to the value of the heat that was absorbed by the ice. I should be able to get the value of C. Is that okay? Can I see a few responses on that calculation? Yes, in the chat. Yes? Okay. So we are winding up. I wouldn't like us to go far beyond this, but let me throw just one more hint. Someone who is saying that I start from scratch, it would be good. I would really love it, but our time is not time is not on our side, yeah? Okay, let me try to throw more light on it. Let me try to throw more light on it. I can't start from scratch because I understand some schools have not covered heat, but maybe from what we've shared here, at least you can have a background, yeah? So why I'm going to share this one. I multiplied by this 4. I'm still checking it out. Just it is a very slight correction that I need to make. But the working remains the same. Our question says that we are having ice that absorbs heat. Ice is initially at -10. Okay. -10 degrees Celsius. The temperature of ice rise. Remember, if you place ice cubes, in these ice cubes in a liquid, yeah, they melt. As they melt, it means their temperature is what? Is increasing. They melt at the expense of the liquid in which they are placed. So as they absorb heat, the liquid reduces in temperature. The liquid in which they are placed reduces in temperature. So that means if these ice cubes are placed in a liquid or in a drink, from -10 degrees Celsius, they'll have to rise to first rise to 0 degrees Celsius. Then from 0 degrees Celsius, still they rise to 0 degrees Celsius. If this is my point A, this is point B, and this is point C. Between point A and point B, there is change in temperature. Theta stands for temperature. Now, between point B and point C, we call that change of state. Constant temperature, but different state, from solid to liquid. Then it goes further from C to D. That is from 0 degrees Celsius to 10 degrees what? 10 degrees Celsius. So this is change in temperature. So if we are to first consider ice cubes alone or ice cube alone, the heat absorbed by this ice cube is going to be from A to B, that is mass of ice, MI, mass of ice, specific capacity of ice, change in temperature from A to B. 0 degrees is bigger than -10. Get the higher, which is 0 minus -10. Then plus, it reaches B. Between B and C, there is change in state. When there is change in state, it means constant temperature. That means I'll multiply the mass of ice times specific latent heat of fusion of ice. That is between B and C. Then from C to D to be the mass of ice times. Now the ice has changed into water at 0 degrees Celsius, whose temperature rises from 0 degrees to 10 degrees. That means I'll multiply by specific heat capacity of water because ice has changed into water. Then times change in temperature. The bigger is 10 minus 0, which is the smaller. So that means that if I have the mass of water, if I have the mass of ice, which is given in the question, specific capacity of ice, it is given. Like I said, I'm going to check on this, why I multiplied by 4. Otherwise, if the mass is given as 0.2 kilograms, then that is 0.2 kilograms. Unless if in the question they say there are 4 ice cubes. If there are 4 ice cubes, that means you multiply 0.02 times 4. So if I know the mass of ice cubes, if I know the specific capacity of ice, the change in temperature, this becomes a positive. Here, mass of ice, specific latent heat of fusion of ice is given. Mass of ice, specific capacity of water is given. That means this value the heat absorbed by ice, I can get its value in joules. Now, after that, I go to another part. The other part is the water into, or the drink into which the ice cubes were placed. That drink, the temperature of that drink doesn't remain the same. It drops. The temperature of that drink does what? Drops. Drops from 30 degrees Celsius to 10 degrees Celsius. Remember, for ice, it was rising from -10 to 10. This one has to drop from 30 to 10. So that means the temperature, as ice cubes are absorbing heat, the drink is losing heat. And therefore, let me write it down here. So the heat lost by the drink is going to be the mass of the drink, specific capacity of the drink, then the change in temperature of the drink. Change in temperature, it is lowering from 30 to 10. Now, from heat absorbed is equal to heat gain, or heat lost is equal to heat gained. We know that, yeah? Assuming no heat losses. That means if I know the mass, if I know this value, which in the question is given as 0.5, CD. CD stands for specific capacity of a drink times 20, which is given as, this is something like what? 10 CD. CD stands for specific capacity of a drink. Now we know that the heat absorbed by ice should be the same as the heat lost by the drink. So that means that heat absorbed by ice is equal to heat lost by the drink is 10 CD. CD is the one I'm looking for. Specific capacity of a drink. So that means that if I have this value, which I calculated from here, if I have this value here, I substitute it in, then I can calculate for this, for the CD. CD is the specific capacity of a drink. Is that okay? Karen, I think that's what we're able to share for now. I'm going to share the solutions. I will share them with Mr. Kaziba. Mr. Kaziba will share with us. Is that okay? So, can I see some, as we are winding up, a few comments, then we call it a day. Someone to give us a prayer, closing prayer. Someone to give us a closing prayer. Yes, sir. Bishop Dunstan. I'm seeing a hand. Kindly give us a closing prayer. But I hope we have picked something. Have we? Okay. Is it possible to unmute? Okay. Someone has. Heavenly Father, now I want to just read this one so that someone has given a prayer. I just want to read it out. Heavenly Father, we thank you for bringing us together today. We thank you for the ideas shared, the decisions made, and the unity we've experienced. As we leave this place, we ask for your continued guidance and wisdom. Help us to carry out what we have planned with integrity and purpose. Bless each person here, protect us, strengthen us, and grant us peace. May we return to our tasks with renewed energy and a heart to serve. In Jesus' name we pray. Amen. Thank you so much. Thank you for this evening. May God bless you.